I'll only tell till 19, 17, 18, 19, 19, 19, 17, 18, 19. Okay, we'll see what is here now. Convex set. A subset CO is convex improves the line segment. Right? Okay, what is convex set? If you have something like this, uh, let me draw this. Let's say all the points in this region enclosed by this is a boundary. Let's say this is some set of points. If I take any point and join it with any other point, it's telling that if the entire line segment is within this, uh, then it is a convex set. But is this actually a convex set? If I take this point and this point and try to draw a line segment across it, some of the points are lying outside, so this is not a convex set. Okay, anyways, I'll come back to what is a convex set. Convex set is basically, okay, what is a set? Set is a collection of some elements, in this case points. So let me say I have some set of points. Let's say all of this is some set of points. When can I call it convex? If I take any 2 points, if I take any 2 points, and if the line segment that joins these 2 points, if all the points on this line segment joining these points lie within this set, then I can declare the set to be convex. So for any 2 points, if you draw the line segment joining them, all those points on the line segment must lie within the set. Only then it is a convex set. Is this a convex set? It is not the convex set, because if I take this point and this point, if I join those 2 points with a line segment, all the points uh, in that line segment are not in the set. You can see some of them are outside. So this is not a convex set. Okay, let us take look at an example of a convex set. If let's say this is there, let's take a circle or something. Is this a convex set? Yes, it is. It absolutely is a convex set. You can try taking any 2 points in this set. You will still find that all the points in the line segment joining these 2 points lie within the set. So this is a convex set. So basically, if you want an intuition, anything that is like circular, ovally, those kinds of sets are convex. If you have something like this, if you have some dips and if you have some dips, like this, some pits or whatever you call them. If you have something like that, they're usually not convex. You should not have like gaps like this. That is an intuitional way of understanding what convex sets are. Okay, C is convex for C. What is this? This is just some linear combination of x and y. So lambda is some scalar there. 1 minus lambda is another scalar. X and y are some points. So this is basically the representation of a line. This is the representation of a line joining x and y. That is what this is. A line segment basically. So it is telling that all these new points are also in C. Okay, C is convex if all the points joining x and y, all the points lying on the line segment joining x and y belong to the same set. That is what is written in maths. In mathematical format, it has been written. If you know some vector, I don't know, you don't. If you recollect this from your calculus part, this is nothing but, if you remember this one, uh, parameterization of a straight line, you will find something like this. So that is what it is. So if you put lambda 0, you will get, what will you get? You'll get x. If you put lambda 1, you'll get y. If you put any other lambda, you'll get all the points in between x and y. That is what this means. So this is nothing but the representation of a line segment joining x and y. Okay, fine. Enough of all of this. Uh, Empty set is convex. Okay, there are no points in an empty set, so okay, fine. There's nothing much to think about it. Empty set is convex. Convex combination of points. What is convex combination? We say that y is a convex combination of points if y is equal to for some choice. Okay, it is just like linear combination. What you do is uh, let's say you take you see you just have some variables x1 x2 x3 and so on xk. There are some points. You multiply each one of them with some scalar lambda 1 lambda 2 lambda 3 and lambda 3 and add all of them. The resulting uh, point is y, but the lambdas are in such a way that each lambda lies in between 0 and 1, but and the summation of all the lambda is 1. If you look at it, this is one convex combination. Here x1 is x, x2 is y, uh, lambda lies in between 0 and 1, and 1 minus lambda plus lambda is 1. So this is a convex combination. You can say this is a convex combination. One example of convex combination. Let's see with a set of all points y to be obtained as convex. Okay, so here see k is 2. K is 2 means you have only two variables. In that case, it becomes a line segment. You can have k is equal to 3, k is equal to 4, and so on. If k is equal to 3, then you will get probably what will you get? A plane? Maybe. You can think about examples of okay. See, line segment. Line segment is a convex set because if I take any 2 points on this line segment and if I join them, all the points lying on this line segment will also lie in the original set. So this is a convex set. So line is a convex set. Okay, we call this a convex combination. No? This one, y is equal to lambda 1, x1, summation of lambda I xi. This is a convex combination. If you add all of those first, okay. So why is this called a convex combination? Because if I vary my k, I will get convex sets. K equal to 2, it is a line segment. K equal to 1 is, what is it? K equal to 1 is basically a point. K equal to 1 is basically a point, so it doesn't matter. A point is a convex set. There's only one point. There is no there's nothing to check. You can't join this. You're joining this point with this point. So what is in between this point and this point? The same point is in between this point and this point, so it is still a convex set. If k is 2, you're getting what are you getting? A line segment. If k is 3, you're probably getting a plane. How will a plane look like in 3D? If you have something like this, you can have, let's say, if this is x, y, z. Let's take the xy plane. Xy plane is like this. This is a convex set because if I take any 2 points on this plane and if I join them, if I take any 2 points on this plane and join them, all the points in this line segment joining these 2 points will also lie in the original set, which is the xy plane. So the plane is a convex set. Hyperplane. I wonder what hyperplane is. Let me see. Hyperplane. Hyperplane. Hyperplane is a generalization of a two-dimensional plane in three-dimensional space. Okay. 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 We'll not consider something. Hyperplane is something. Hmm. Okay. Oh, from what I've understood on just read few lines, if uh, if Rn is your space, then any some subspace of Rn, let's say it has dimensions n minus one. Something related to this is a hyperspace for hyperplane. For example, if there is R2, R2 is, how does it look like? It looks like this. You have y and x. So anything in the R dimension, anything that is one dimensional is a hyperplane. So I think in two dimensional case, a line is I think a straight line is a hyperplane. And in R3, I suppose hyperplane is something related to R2. So I think a hyperplane in three-dimensional case is a plane. Higher dimensional cases, I don't know. Mm, this is a very crude understanding, so you can probably Google later what hyperplanes are about. Examples of convexes. Interval in R is convex. What is R? R is a number line. If I take any interval, that is also a convex set. Unit ball is convex. I have some ball, some 3D ball. Uh, okay, 3D. So it's full. Every point in this every point in this ball is also ball. No, ball is solid. It is not a hollow sphere. It is a ball. So if you take any 2 points in or outside this ball, as long as they're a part of the ball, anything, if you join them, all the points in the line segment joining those 2 points will also lie in the convex set, will also lie in the set, and therefore it is convex. Triangle, tetrahedron. Okay, triangle, I see, very much obvious. Triangle, you join any 2 points, all the points on that line segment will lie within this triangle. Tetrahedron is this 3D structure. See, some 3D structure. You join any 2 points. Nice. Okay, they're giving a matrix, M by N matrix. M by N matrix. Then X belongs to Rn. I have M elements here. 1 to M. I have 1 to N. And B is in Rn. I wonder what this is. Maybe look at it in your free time. I don't have the time to think about this now. We'll see about it later. Examples of convexes. Okay, ball of radius. I think it's a disk of radius something. Okay, they said ball because they did not mention what dimension it is. If it is R2, it would be a circle. If it is R3, it would be a sphere. Higher dimensions, I don't know. There might be special names for that. But in general, they gave it for all dimensions. Some Rn dimensions, n dimensions. So Rn is the space. Hmm. So let me write it here. If n is 2, it will be a disk. If n is 3, it will be a sphere. Higher dimensions, I'm not aware. If n is 1, what would you have? Maybe a point. If n is 1 dimension, you only have a point. Higher dimensions, I cannot draw. It is not possible for me to draw all of that. Epsilon is like the radius. That's what that is what is given. Ball of radius epsilon. This is the set builder form, right? Set of all points x belonging to Rn such that the norm of x, the second norm of x is less than real. This will give us a distance basically. Distance between the origin and x. So it is nothing but this one. It's just x1 square plus x2 square, so on, xn square under root. So in 2 dimension it will give you distance. 3 dimension also it will give you it's distance basically. That is what is given here. In matrix notation it is given here. Matrix notation because I can represent x bar dot x bar as nothing but x transpose into x if I write vectors in terms of matrices. I am doing something very similar to dot product here. I mean, if it's getting into your head, it is fine. Or else you can just. It's just an example. Uh, okay, yes, general example. Distance between x and y is x minus y. You take the norm. Okay. I mean, I do. I think some of you do know. I can write vectors in terms of column matrices. Some of you might know that. You can take an example. Okay, fine. You can just look at it. I just told you. You can look at it yourself. Convex cone. Okay, what is the definition of a convex cone? Conic non-negative combination of x1 and x2. Any point of the form. Okay. This equation represents a convex cone when theta is okay. What is a convex cone? Hmm. I have x1 and x2. I'm varying my theta. Theta is it's just a parameter there. I don't think there is any angle or something of the formula. So it's like if theta one is zero, uh, let's say this is the direction of x1 and let's say this is the direction of x2. Okay, I think the points are given here. Uh, it can't be, okay, let's say I think this line represents everything when theta 2 is 0. If theta 2 is 0, there will be x2 will not affect my equation. So all my points will be like something like 1 into x1